Okay, I think let's kick off. I'm conscious of time, as always. Good morning, everyone, and welcome to the first mastership session in the third semester of this year. We have a very exciting lineup for you this semester, and we really can't wait to get going. We're kicking off today with a very, very special session on biomimicry, and I'll introduce our facilitator and our speaker to you in a moment. A couple of housekeeping things, please. As always, please do be conscious of your background noises and keep your speaker on silent if you can. You're welcome to unmute yourself if you do have a question. We're going to deal with questions slightly differently today. Instead of you being able to unmute yourself at any point in time, what we'll do is at the end of every section, Claire will stop and invite your questions on that particular session. At that point, you can also put things in the chat and we can read them out to her and ask those questions of Claire and move on in that way. As always, there is a feedback form, and I've just posted the link in the chat. I'll do that again at the end of the session, but just so that you can give us your thoughts and comments on the session itself. So I'd like to now introduce you to our speaker today, Claire Janisch. And Claire, I hope I'm pronouncing your surname correctly. Claire is the founder and the founding director, in fact, of Biomimicry South Africa. And the CEO of the learning arm of that called Learn Biomimicry. She spends her time exploring nature's genius in diverse ecosystems, and she shares this new way of viewing and valuing nature through biomimicry expeditions and a whole bunch of coaching. If you think biomimicry sounds airy-fairy, please don't. Claire has a master's degree in chemical engineering in industrial ecology, and she's actually worked across Africa as a sustainability consultant, specializing in things like cleaner production for industry, agriculture and urban systems. She was selected in the Mail and Guardian's 200 Young South Africans for 3 consecutive years, which gives you an idea of how exciting this particular field of study is. And in her free time, she's a holistic health practitioner, specializing in kinesiology and biofield tuning, which sounds exciting in its own way. Claire, we are delighted to have you. Thank you so much for joining us today, and over to you.
Yeah, hi, good morning, everybody. As per usual in South Africa, we have load shedding here I'm in Nature's Valley in the Western Cape, and so I have had to come to a coffee shop, which might create a few distracting sounds in the background because it's actually on a farm. So the tractor just drove by, people come and go, but it's the best I can do for now. So I'll do my best to keep the background noises down by muting when I can, but I have to apologize, but that's what life is like. When you live your life in a rural area. Okay, so I'm gonna turn off my video and then share my screen and get started. So the whole idea of biomimicry is that we want to apply biomimicry to enable us to innovate, to really just think outside the box. And it's critical for us to do this at this moment in time for so many reasons, because we're under enormous pressures to change and innovate for so many different reasons. From the sustainability field where I'm in, it's very obvious. But then even just in terms of adapting to rapid change, like what's brought about by the pandemic and the fourth industrial revolution, we need to just really start thinking outside the box. But in the biomimicry's case, we say think outside, because right outside in nature, we have some extraordinary opportunities to discover innovations that truly work for our context. So biomimicry is the process of being inspired by and learning from nature, quite made famous by the Shinkansen bullet train that changed its front of its front shape structure to quieten it as it went through the tunnels. Ignore the cows in the background. I think they agree with this, but by copying the kingfisher's beak and how it doesn't make a splash as it enters into water. So biomimicry, if you wanted a definition of it, it's a practice, meaning you get better at it the more you do it, as opposed to it's just a skill you learn once. So the practice of learning from nature, not learning about nature. So any of you who studied biology, you would have learned about nature, whereas biomimicry shifts that lens and say, what can we learn from nature in order to emulate what we find? And the word emulate just shows there's respect in that word. If you just said copy, it's not the same thing. So bios meaning life, mimicry meaning to emulate. It is the practice of learning from and emulating nature. And why do we do this? And this is a quote from one of my colleagues who wrote the book Teeming. Radically disruptive ideas emerge from simple observation of the living world. They're transformative, surprising, yet somehow obvious. So that's the one thing I really wanted to highlight for you, is that once I show you some of these examples, you kind of realize how obvious they actually are and why we haven't been doing this for decades, because people like Leonardo da Vinci and Buckminster Fuller are kind of famous for having said, you know, copy nature, make nature your master, and you'll see what innovations and genius can emerge. And they were both considered geniuses of their times. And we're looking for disruptive ideas right now, because you either disrupt your own company or somebody else. Well, this fourth industrial revolution is driving extraordinary change, which many of you are aware of in your field. You'll be aware of it, but driven by mostly the invention of the computer and the microprocessor, and then the digitization of so many things, but then enhanced by many other technologies that are growing exponentially. And this is unexpected for all of us, and because we're not used to this kind of exponential change. So these exponential technologies that you might have heard of and may know well, what I love to point out to people who are unaware of it, that even whether it's deliberate or not deliberate, every single one of these exponential technologies is in fact biomimicry. If you think about it, robots are mimicking either human capabilities or the capabilities of other organisms. Drones are trying to attempt silent and agile flight, like dragonflies and birds. Nanotechnology, we'll discover as I show you some examples, is not a few decades old, it's millions of years old. Nature's been exploiting structures at the nano level for centuries, for hundreds of years, hundreds and thousands of years, millions of years. Then neural networks, artificial intelligence, and deep learning, that's all about mimicking intelligence, right? Smart sensors and the Internet of Things, think about the 5 senses of your body and your central nervous system. I think as we start to study not only those of the human body, but those of other species and the ability to sense in extraordinary ways, we can really advance our capabilities in this. And then digital platforms like the blockchain and Airbnb and Waze are really exploiting swarm intelligence and the capacity for interactive interaction in a distributed nature. I like to really show people this image and say, isn't additive manufacturing been happening for millennia in nature? Nature grows cell by cell in a way, doesn't cut out the leaves from a large piece of cloth or any other complicated way, and it does it with the lowest amount of energy you can imagine. And then it comes to data storage. I mean, as we run our world on software and have to start to store all of that data, we're getting these huge, big data centers that cost billions of dollars to keep going and to build, and they require large amounts of energy to keep cool. What about DNA? DNA is able to store large volumes of data. And we know that DNA is stable at room temperature and can last for hundreds of thousands of years. So the weight of DNA needs to store the world's data is approximately about 1 kilogram of data. And there's a large number of companies that are figuring out not only how to store data on DNA, but actually to extract that data at quite high speed, known by the company Cache DNA is one of the more famous ones now. But a few grams of biological media in a tube will replace a 1 million square foot data center. They've just been storing data in way more advanced ways for a long, long time. Even we are running on this potential, this actual hardware. And we have sustainable energy, mimicking a leaf. So what we point out, as much as all these experimental technologies are extraordinarily smart and really advancing by understanding how nature works and trying to mimic and in many ways replace what nature has been doing already, what they're missing is the extraordinary wisdom that is inherent in every single one of these so-called natural technologies. If I just go back to the leaf and the solar panel, just from an environmental point of view, the solar panel is made using vast amounts of fossil fuels. Usually takes about 6 years to pay back the carbon footprint of a solar panel by capturing the energy of the sun. So it's actually emitting carbon in its manufacturing. When it's being made, it's made with very toxic chemicals, same as for computer manufacturing. And when its life is over, it ends up in landfill site, causing bleaching. Now, if you compare that to a leaf is actually made by breathing in carbon dioxide and turning that carbon dioxide into an advanced chemical that's able to store energy. And then at the same time, it's made out of it's making this exquisite plastic, and it's doing everything just using the energy of the sun while breathing out oxygen, which is balancing the cocktail of gases that sustain life. It's driven by evapotranspiration, which brings the rain cycle and actually brings the rain and contributes to the water being enhanced in our world. And when its life is over, it ends up on the soil, building the soil as compost and providing many opportunities for more species below it. So this exquisite wisdom that's inherent in natural technologies, the capacity for this not only to capture the energy of the sun, but to use the energy of the sun to do it, to breathe out oxygen, to breathe in carbon dioxide, to contribute to all the conditions that are essential for creating life and for contributing to life. This is the level that biomimicry can expand to, and really it's exciting when we start to push human capacity to evolve our own genius and wisdom, to go beyond just trying to be clever, but starting to be wise as well. So our evolution has led us into quite a predicament. When we look at the first industrial revolution, the second industrial revolution, the third industrial revolution, every one of them has brought the most terrible mess and waste behind them, having worked in the number one field that causes all of the mess, which is chemical engineering. I know firsthand what this mess is, and it is very embarrassing for humankind. And it's time for us to actually look at this fourth industrial revolution and say, should it just be intelligent, leaving even more waste and destruction behind it and replacing nature with so-called technological advancements? Or should we start to figure out a way that we can integrate the best of nature's genius with the best of nature's wisdom and design a world that is actually truly exciting for us to be part of, and maybe use that exponential curve of change towards a flourishing, thriving world? So why should we learn from nature? Whether you're a biologist who believes in 4 billion years of research and development, which is 4 billion years of evolution, or whether you're a creationist who believes that God's mind is equivalent to 4 billion years of research and development, no matter what, it's truly extraordinary when you study nature and find out how much it's understood. Every aspect of every organism not only meets its own functional needs, which are very similar to our functional needs, but does it in a way that nourishes life. And that's because every single one of these creatures is aware that we're on a spaceship Earth. We're in a very fragile spaceship, and if you want to do any kind of mastership, it should be mastering the spaceship, because it is an exquisite spaceship, and we're traveling through space. We're oblivious to the fact that we're traveling through space because we're in this orbit that's able to sustain life and create the conditions perfect to nourish ourselves. And we should be looking to nourish the spaceship before we head off into Mars and try and figure out how to colonize another one. So there's over 30 million species on the planet. That's an estimate, and there's hundreds and hundreds and hundreds of thousands of subspecies and many organisms. There's so much potential for us to learn from the web of life, and it's very exciting. As I've spent over the last decade looking for solutions to some of the world's biggest challenges, we find that they're always lying somewhere in the natural world, especially if you expand your mind to open it up to more of a systems worldview. And one of the genius discoveries of the biomimicry group is this extraction of the sort of overarching patterns and principles that we find in every single organism and every single ecosystem on the planet. And we call them the biomimicry guiding principles, or life's principles. And there's 6 guiding principles that, if we actually integrated these into the design of our world, the design of the products, processes, and systems of our world, we would too be able to create conditions conducive to life as what we do, but also be able to adapt to change continuously, as every organism has learned to do as well. So the rest of this presentation is really taking you through these 6 overarching guiding principles as sort of critical skills that I think everybody in the world of business, or in the world of government especially, needs to understand and apply. And I'll show you how they work and how they're applied in the world of biomimicry. But I'm going to pause now and ask if you have any questions in the meantime.
Please do share the
presentation
with us afterwards. That would be great.
Sure, I'll share a PDF because it's very large with large images in it.
Yeah, you could just forward to me, Claire, and I can
pass. Martin's just shared this golden spiral scene in nature. I have a 3-day workshop on just the golden ratio and how profound it is in terms of its impact and understanding efficiency and many other things, but I'm not going to do that today. Okay, well then I will continue with sharing. I just needed to make sure you were all still there and I wasn't talking to the cows in the field. Awesome. So agility, this one you guys will like because it makes sense and the software world understands the need for agility. In fact, I think the world of software is one of the few places that can truly understand the genius of biology, because biology and software are very similar. So we know that the world has been used to organizing its understanding of ourselves in very structured and hierarchical ways, but the truth is that it's never is that structured and hierarchical. It's always been chaotic and integrated and connected, and everything that you do has an impact on something else. And even if you try and organize your organization in the ways we used to, with this line of pathway in the very bureaucratic way, you can just, anyone who thinks of Home Affairs in South Africa, and you understand how useless that method of organizing actually is, and how much more we need to move towards this agile understanding of these interconnections. But the one on the left is very simple, and the one on the right is complex.
We've lost your presentation
for some reason. That's weird. Okay, let me try again.
Just share again.
Did it just pop off?
Yeah, it just disappeared.
Let's try.
Enough.
Can you see it now?
Not yet. Yes, there we go. Back. Thank you.
All right. Awesome. So what I like to point out to people is the one on the right is the way the world actually works. The one on the left is the way we try and use our simple minds to try and sort the way the world works. And humans actually work that way too. So as much as we try to organize them in hierarchies and treat them like a machine, they are not. And the impact of the pandemic and forcing everyone to work away from this sort of controlled bureaucratic structures that most companies have been operating under is making us realize how false that actual simple attempt to organize humans actually was. And so agile is the mindset to get us through COVID. Companies in more volatile or uncertain environments are more likely than others to pursue agile transformations. What I love about this particular diagram is it just describes agile in a way that helps us understand the power of it. We want to be able to be dynamic in times of change, but we also want to be able to be stable. And in order to balance both dynamism and stability, nature's actually got that so right in so many ways. And what we need to look at is how do we actually abstract from nature those principles for agility, so that we're not sort of heavy on the stability, which is the bureaucracy and frustration, and we're not so heavy on the dynamism that we lose stability. And if you see this report from McKinsey, that 5 trademarks of agile organizations, he said we actually need to move away from the perception of organizations as machines to the realization that organizations are actually more like organisms, and need to be able to be flexible and adapt to change, and leadership that shows direction in different layers and different hierarchies and horizontally, and that there's teams built around end-to-end accountability. And so what we have got is a whole bunch of people in the biomimicry world who are actually abstracting the principles of agility and applying them to organizations. One of the more well-known ones is Ken Thompson's Bioteams and Biohacking the Organization. How do you move to distributed planning and management of organizations and teams? This is even for top athletic teams as well. So this is a creature known as slime mold that will demonstrate to you the power of agility. I'm going to play a video, and it may not work so well. I'm going to, hopefully you will hear some of it, but if not, I'll send you the link to it. But this is one of the greatest geniuses and wisest beings in nature for achieving agility. It's actually one organism, but it's able to find a resource across the forest floor, and in a way kind of senses the environment rapidly, runs on feedback loops, and self-organizes itself in an extraordinary way. So let me play this video. Hopefully you'll be able to hear it. If not, just let me know as soon as possible.
Anthony here for D News, and I've been wondering, what makes us intelligent? Is it our ability to reason, our decision-making skills? Is it our memories? If any of that is true, then where does intelligence stop? Are dolphins intelligent? What about dogs? What about mold? This is Physarum polycephalum. It's a slime mold that scientists sometimes call SpongeBob SquarePants. It grows in this weird oozy form and eats by slowly enveloping bacteria, spores, and any other nasty little bits it encounters along the way. It's a single cell organism, so it doesn't have a brain or a nervous system. And that's what makes some of its abilities really interesting. Scientists have been studying it in labs for about 30 years, and they continue to be surprised by it. Put P. polycephalum in a maze with a bit of food at the end, and it grows perfectly through the maze to find it. No wrong turns. That sounds like ability to reason. Put a few different kinds of food in front of it, and it will grow towards the healthiest one. That's making smart decisions. And as it travels throughout the forest or a lab, the mold leaves a chemical trail behind it that lets it know that it's explored a space before, so it doesn't grow that way again. That sounds like a form of memory. And then there's the way that P. polycephalum builds itself. A study by a British university showed that the slime actually builds perfectly optimized routes between destinations, and they propose using it in city planning. Just make a tiny model of the terrain and put some food where major destinations are, and watch the slime build your roads and transit systems.
So, I'm terribly sorry that the tractor decided to come past during that. Did anyone actually hear that and get the basic understanding of the genius of slime mold?
Yeah, that was fine. Thanks, Claire.
Okay, awesome. So I'm going to show you this other video. This is a video of actually slime mold, SpongeBob SquarePants placed in the middle, representing Tokyo in the map of Japan, and all these delicious oat flakes for the slime mold, representing the outlying cities from Tokyo. And what they did is they left the slime mold to map the pathways, the optimum pathways between all of these cities. And you'll find there's not only every pathway is the most optimized, but every single pathway has a backup pathway as well. So it's extraordinary optimization. And when they compared that to the roads and rail network, they realized there was much to learn for optimization. Of course, it was in 2 dimensions, and in 3 dimensions it would be more interesting, but it's just a really interesting idea to think we could replace most of our transport engineers with a slime mold that could do the same job in 26 hours. So we have the idea of swarm intelligence, right? This capacity to rapidly learn from each other and to make decisions as collective intelligence rather than going through a centralized mind. The ants are well known for doing this. You know, as ants leave their nest, they head off to find food. Those that find food come back leaving a very important signal or feedback loop on the ground with a trail of pheromones that says there is food here. And you'll see that the next group of ants leaving the nest will smell those trails and know exactly which trails to follow to find food. And the one that is the shortest trail gets reinforced by all the other ants as they come back, leaving this trail back on it. And so quickly the shortest route is found by all the ants. And there's a group of biomimics known as mathematicians who look at ant colony optimization, learning for how ants do this rapid feedback loop and apply it to different things. There was a student from the University of Johannesburg who applied it to optimizing the routes of the post office. No surprises here that they were able to increase the optimization by over 50%, saving the distance traveled by the trucks by a lot and the large amount of diesel at the same time. But we apply this kind of swarm intelligence every day. We use the Waze app, and the app is a platform that enables peer-to-peer or distributed exchange of information. So we can all post information about the traffic, and we can then self-organize our routes through it without having some centralized intelligence have to do that. We do have a centralized platform, but it is able to be distributed through apps as well. So this idea of digitization driving the future of exponential organizations is really exciting, because it is actually this potential for us to connect all the parts of the system in a way that can be a super swarm intelligence rather than relying on only one central part to make the decisions for the whole. And there's many applications of self-organization and swarm intelligence in the world. This is one of my favorite. This is Unanimous AI, where they've combined the artificial intelligence with swarm intelligence, where they combine the AI technology, but they combine it with people. Can humans swarm is the question they ask, because it's not just applying the artificial intelligence, which mimics the human brain, but the artificial intelligence learns from the wisdoms and insights and intuition, which cannot be mapped by artificial intelligence. It can only be learned from. And so what they do is they have a swarm interface, an AI engine, and then the capacity for humans to be part of this. And they apply them to different tasks. The one task here was, could they predict who would win the Kentucky Derby? So they take 20 horse enthusiasts, horse racing enthusiasts, not experts in any way, and they apply this system to them, and they found an answer. group the results. Oh no, it wasn't just one answer. They had to do the top 3, the trifecta, in the right order. And so they took all of the answers and they submitted them to the groups, and then individual answers they found the average, and then they found the AI swarm response. And then they called a reporter and they said to the reporter, this is our prediction for the top 3 in a row in the correct order for the Kentucky Derby. Would you go and place a $20 bet? And if we're correct, then you can report on it. And they were 100% correct. $20 was turned into $11,000. And since then, this particular thing has been used to predict results of sporting events quite effectively. Sports Illustrated calls some of the most accurate predictions of racing has ever seen, more accurate results than traditional polls. Then they used it also to predict, this was before Trump was ever an elected president, who would win the Republican caucus, and it accurately predicted Trump as well. And they use it now to help organizations to predict what people would be happy to pay for specific things, like, you know, the cost of a movie ticket. And there's many, many companies now using this potential to absorb the wisdom and genius of the whole rather than being channeled to one individual. So that's agility, the potential for us to learn from nature in the form of how we can learn to rapidly adapt to change. It's just some ideas, but not all of them. Any questions so far?
Nope, we've got comments on the chat, Claire, just so you know, saying we wonder how many of our developers we can replace with mold slime.
Okay, well, I'll read slime mold comments later. Slime mold is my favorite, and that's what I think.
Yeah.
If we think nature isn't, if we think we're intelligent, look at how slime mold can far outcompete us in many of the things we do. So now we have innovation, and innovation is really quite exciting for me because, you know, you can invent amazing robots. This is a particular robot that we launched at UCT the other day, about a few years ago when we brought Festa out to South Africa, and you can see the absolute awe and excitement everybody had at seeing this robotic bird that's, you know, being able to flap its wings like nature. But a normal seagull will fly over their heads every day and nobody will bat an eyelid, and suddenly a robotic one is like everyone's in awe of the absolute advanced, you know, genius of flapping wings. So how advanced and genius is nature itself for us to start to learn from. But the purpose of mimicking nature's shapes and structures to innovate is not actually just to make them the same. Yes, there's some advances we can learn from this, but the purpose is really to improve efficiency in many ways. This is quite a well-known example of a seed that everyone might see. It's called a helicopter seed. As it falls to the ground, it spins round and round. But why does it not make a sound? You know, why do helicopters and fans make so much noise, but this particular seed is so beautifully silent? This was a question an industrial engineer asked, and he said, well, there must be some, you know, really extraordinary fluid dynamics for it to not make a sound. And it's not just because it's small. And he went and ran some algorithms and did some tests, and he worked out that actually it's just extraordinary at reducing friction. And so he tried the best thing he could first, which was to, you know, use it for a ceiling fan because he couldn't apply it to a helicopter first go. And he not only resulted in a completely silent fan, which is quite lovely for those who want to go on a tropical holiday and rest and not be woken up by a tornado above your head, but it also was 75% more efficient, and it's exquisitely beautiful. So I just wanted to point this out, that every single day we've seen these seeds, but not one of us asked those questions, like what could I learn from that seed? And there's many, many more examples. This is the humpback whale. Don't know how many of you ever noticed that the humpback whale has bumps on the front of its fin. You know, surely such a huge creature that turns, you know, tight spirals underwater, almost like a double-decker bus making pirouettes. Surely it would actually have not such a gross problem of reducing its fluid dynamics. Surely it would want to actually increase its fluid dynamics. And it turns out that this tubercle edge of its leading edge of its fin actually super advances its efficiency at cutting through water and its ability to turn circles without actually causing a lot of drag and without any. And they've applied this to many different things, from wind turbines for the company whalepower.com to fans in our laptops, to ceiling fans, and even to airplane wings, and has the capacity to reduce drag not by 1%, which we get excited by in airplanes, but over 30%, and to increase lift at the same time. So this amazing idea of how we can learn from a simple shape observed in a whale to advanced things that move in the air and in the water. Then we have the nano level of shapes that we're starting to learn from in the natural world. this one's quite apt for the moment, because what we can learn from the shark skin. Turns out the shark skin doesn't let anything stick to it, not even water, which is why the Speedo swimming costume was so successful. But what we're looking for now in the world is ways to reduce the impact of pathogens. So pathogens like bacteria and viruses, we spray with sterilizers or sanitizers. And in hospitals, it creates large amounts of problems where we breed superbugs that are able to resist these sanitizers. It turns out that the shark is able to resist the growth of bacteria or anything, algae, mold, barnacles on its skin, by having a raised surface that looks like teeth, so it's denticles. There's a company called Sharklet that simply mimic that principle and applies a thin film to any surface, from hospitals to dummies to your cell phone cover, and actually prevents the growth of bacteria on that surface, and prevents the use of you don't need to use chemicals like sanitizers to achieve the same effect. And they even applying it to things like yoga mats. And if you think about the systems-wide impact of spraying chemicals like sanitizers all over everybody's hands, all over every surface, being washed down every single drain, washed into our water systems, and killing the biological life in those water systems, and severely treatment works, you can imagine that a being in nature that figured out how to manage bacteria would do it in a way that doesn't destroy the systems that it depends on for life at the same time. Then we have the lotus effect. Many of us have seen these lotus leaves emerge from muddy water perfectly clean, and we see the water bunching up off of the leaf, so it doesn't actually stay on the surface, so that the leaf can successfully photosynthesize. If you zoom into the leaf, you'll find at the nano level that there's just a lot of raised edges, and there's more air than there is solid for the water to attach to. So water will form up into balls like raindrops rather than attached to the surface. There's many ways you can apply this particular surface structure to something. This is a honey pot. You can imagine how great it would be to pour honey off of something without having anything stick to it. That's just one application, but what if we applied it to something like this? How much less turpentine, how much less water would we use, how much less waste would we generate, and could we just reuse those cans over and over again? So the power to shift to a next level of innovation by studying nature's nanotechnology is quite extraordinary. And we now have the capacity to mimic nature at the nano level better than we ever have before. It might take us a while to get it to be cost efficient, but we now have the capacity. And the 3D printing, we can take almost any shape in the natural world, and its internal structure or external structure, and scan it into software and be able to print it for various potential applications. And we can actually now get to a point in our world where we're not shipping materials around the world, but we could actually just ship software around the world. And then we could start to look to nature for ways we could reduce those materials. Now, dematerialization is enabled by software, right? We can replace all of these different products with one, but that one product is still made out of materials that need to be made in ways that are life friendly. And that's the exciting part for someone like me in the chemical engineering world. How can we ensure that this one beautiful piece of technology that can achieve so much doesn't actually cause massive amounts of waste and havoc in its background? Okay, before we go into life friendlies, any questions on innovation and potential for us to learn from nature's shapes and structures?
Nope, nothing on the chat either, so I think we can go ahead. Thanks.
Nope. Awesome. So now we have life friendly. This is very interesting for me because remember we began with the leaf. Well, this is a company called Novum that actually has mimicked the way a leaf can turn carbon dioxide into a plastic. And they take carbon dioxide from flue gases, and then they apply the same enzymes that turn carbon dioxide into lemon peel, which is beautiful plastic. And they may able to produce a biodegradable, biocompatible plastic from carbon dioxide. So turning that cycle of carbon back on itself. And Ford is going to be making car parts out of the Novum plastic soon to try and close the loop on their carbon cycle. So many of us talk about carbon as a pollutant. Carbon is not a pollutant. It is the basic building block of all of life. And anyone who talks about how we need to decarbonize industry is just silly, because, you know, it's like decarbonizing is like taking the structure out of all of life. We need to figure out how to recycle carbon and emulate natural cycles and turn carbon into new materials. And every single one of these recipes I show you now that could replace all the parts of your cell phones are actually using carbon as a raw material. This is also applying the idea of photosynthesis to the plastics. If you put the plastic in, you lay it on top of that, a particular thing like chlorophyll, which is basically a pigment, and you put a pigment mixed with a very light white powder, you can generate electricity, which is in a very efficient way. That's not mimicking, it's not the same as silica paste, but it's the same as biological materials. And G-cell is leading the way on that. But this material you might have seen before. Anytime you've eaten at a seafood restaurant and you throw in crab shells or lobster shells or shrimp shells away, that becomes a waste and it goes into landfill. But this organization, which is part of Harvard University, took that waste shrimp shell and turned it into a mixture between that amazing material, which is the second most abundant material in nature. It's a very tough and lightweight material. Think of any exoskeleton of an insect, and they mix it with some silk to give it some flexibility. And the image you see above that Vice Institute logo is the replica of an insect's wing that they made from this. It is a fully degradable bioplastic derived from shrimp shells and silk protein, and could provide solutions for planet-clogging plastics as well as implantable medical devices. If that ended up as plastic in the ocean, it would be food for every creature in the ocean. And if it ends up on land, it becomes compost. We can grow more. And you might think it's quite soft and not tough, but this is the mantis shrimp, which is able to basically strike a massive blow that creates sonoluminescence under the water. And we've studied that material, and it's one of the toughest materials known to mankind. And we looked at the structure, and if we apply that particular structure to chitin, we can achieve super tough materials that could actually be used for everything from helmets to car parts. And actually, we could make computer components out of this tough and lightweight material that is very strong. And that's a company called Helicoid Materials that is achieving that. And then we have the world's greatest embarrassment to chemical engineers, otherwise known as a spider, which is able to extrude a material 5 times stronger than steel, 2 times more flexible than nylon, and the equivalent of Kevlar out of its butt. And if you study the nanotechnology coming out of its butt, it's quite advanced. When we make Kevlar as chemical engineers, we boil petrol in sulfuric acid at 750 degrees Celsius, and we extrude it through high pressure. When this creature makes the equivalent material, it literally just takes some dead insects, some water, and at the temperature of a cold-blooded animal is able to make a material tougher and more stronger and flexible than all of those others. And there's a number of companies that have managed to emulate the spider's recipe by fermenting amino acids and by extruding proteins in interesting ways. And one is Spiber. They've made a moon parka with North Face jacket, which is a tough and lightweight and potentially bulletproof jacket, and the Lexus kinetic seat, which is a shock absorbent seat for the Lexus racing cars. And they reckon that by understanding nature's protein materials, we could have a revolution in manufacturing, replacing all materials with life-friendly ones. Another company called Spintex is doing something similar. So we have the potential to take the most abundant materials in nature, cellulose, chitin, polymers, biominerals, and keratin in the form of things like nails, hair, and feathers and bones. And by replacing those with recipes that we actually are able to emulate, or emulating those recipes, we could replace all of the materials that we use in the human world with natural materials that can continuously cycle, build the soil, use carbon as a raw material, and run on recipes that use such low energy that they could run on renewable energy, which is a revolution that I'm very excited that we could potentially lead, even if it takes the next 100 years of human ingenuity. Any questions on life friendliness?
The comments in the chat, Claire, is around things like, we have no questions because our minds are just blown. This is incredible stuff.
Okay, good. Well, good. Mother Nature's doing a good job. The quietening human cleverness is the important part. So then we have resilience, and resilience is very important for us today with the rapid change. And this is a review from, well, this is a document from Harvard Business Review, The Biology of Corporate Survival. Most companies are dying younger and younger because they're failing to adapt to increasing complexity. And there's a graph in which US public companies were delisted by year, and it gets younger and younger every year as we go forward. So we need to be able to learn to be more resilient. And what I did is I took the list of the principles for resilience from this, starting with this one quote, which is, we stress that companies are identical to biological species because both are what's known as complex adaptive systems. Therefore, the principles that confer robustness in these systems are directly applicable. to business. And so look at their list of how you achieve robustness on the left: be heterogeneous, modular, redundant, reduce uncertainty, create feedback loops, foster trust and reciprocity. There's the modular, there's the integrate unexpected, there's the decentralized, there's the diversity, there's the feedback loop and cooperation. They've only got some of them, there's many, many more, but that potentially we can learn from nature and how to build resilient organizations. And this is one of the main things that I do with the Global Leadership Program, and we apply exactly the same principles in designing resilient cities as well, and resilient buildings. And we've worked with the companies and organizations that deal with disaster, well, basically reacting to disasters, and we apply the same principles to those as well. And the one amazing thing in resilience is the way that nature uses feedback loops. Anyone in the world of software will understand the power of feedback loops, but this one example really just emphasizes it. If you gave a Rubik's Cube to a blind man and left him to try and solve it randomly, it could be solved in something like 1 in a billion years or something. It's really like intensely bad potential. But if you just had somebody there who knew how to solve the Rubik's Cube and gave him a simple feedback of yes or no when he made a move, he could potentially solve it in under 2 minutes. So the power of effective feedback loops is what not only enables agility in an organization, but also resilience. How many of us have electricity meters in some far out hidden place in our house that we haven't seen before until they were replaced with the ones where we have to pay as you go? We used to get a bill in our sort of home, like, you know, post sometime a month later, and we could not have gone backwards in time and changed our thing. We can only then react slowly to this information. So a lot of companies are now figuring how can we speed up the feedback loops to shift behavior, and apps like the Smappy app, which connect to all the electric appliances in your building or your organization and are able to tell you which ones are using what, and in real time figure out how much money you're wasting and be able to switch them on and off using intelligent feedback loops. I think we have the potential to adapt rapidly. If we apply that same thinking to any of our systems and apply them in a way that we could enable systems, we have highly effective solutions. So we've moved away from centralized and decentralized systems in software to distributed systems like, you know, the internet. Social media enables us to connect one to each other, and rather than going through a central space, although the internet itself is becoming that central space. But what if we did it for hardware? What if instead of having one centralized, you know, power supplier like Eskom, which then if it fails, the whole system fails? What if we had more decentralized systems? Or what if we had distributed systems? What if every house in the world, every space in the world is capturing and basically generating energy from a diverse way of doing it, all across a distributed way, and we're able to feed that energy into a smart grid that could rapidly adapt and evolve and move the energy where it's needed in a system. It's far more resilient. What if we did it with water? Instead of one large centralized dam that could run out of water, what if we could distribute that water catchment across an entire area? And what if that was all diverse as well, not one way of doing it? That's the way nature does things. You know, a monoculture will fail, whereas a forest will flourish. And just like, you know, permaculturists mimic those diverse systems to create a healthy, robust agricultural system. We're starting to do that with the internet, because if we had a failure of Amazon, Facebook, and Google, the entire internet would almost be down. So we have to put resilience into those systems by not only having a distributed internet, but also a diverse one, and safe network and solid kind of thinking. But this idea of distribution is really important in hardware. You know, the centralized computer of the 50s is laughable compared to a cell phone today. But the centralized energy production of 1888, known as a power plant, is exactly the same thing that we are using in South Africa today. There has been absolutely no innovation, and it's highly embarrassing, to the point that we've now got a few solar panels and a bit of wind, and we're trying to enable people to do more of it. But how much further could we actually go? This is the work by MIT. The top image is an image of the hand on the phone. Just the difference in temperature between the man's hand and his battery could actually create a potential difference that could drive the charging of his phone. And the picture below is just how the vibrations of a voice as speaking on the phone could actually be converted in and can charge your phone. So women would always have far better than men. the power of this is to recognize that everywhere is there potential difference, and everywhere in nature exploits an extraordinary distributed energy grid for enabling its energy needs, and we can do the same. We just have to apply the same innovation as we have in software as to energy as well. And then if we apply that type of thinking to not just a distributed smart grid that was based on some solar panels and some wind, but all over the place, and we could enable exchange of that energy through the blockchain, we could have a really exciting time where our energy is abundant. And then you couple that with 3D printing all across the country with these abundant materials that are made from natural recipes, and we can start to have a completely different distributed world where resources are more freely available and energy is more freely available. And the one company in the world that actually is combining the blockchain with energy exchange is Power Ledger in Australia. And I do recommend you look up what they're up to. So we have this amazing potential for these exponential organizations, not just to be centralized, which is where they're going, but to be more distributed. And we have this evolution from sort of artisans who worked on their own to centralized to get more and more efficient, to now with the internet being able to us to be those individuals working on our own again, but now as a collective intelligence, rather like slime mold. Life did not take over the planet by combat, actually, but by networking and cooperative relationships. So we have the potential to actually shift our economies as well to be distributed, moving away from concentrating the wealth in the hands of a few to a distributed economy. Not because we're becoming socialist, but because we can use things like the blockchain and things like availability of resources in a distributed way to enable that shifting away from centralized to more resilient distributed systems. And this is the work of an economist known as Kate Raworth, who said we actually have to move to designing our systems to be distributed by design. We can't just hope that at some level, after concentrating wealth in the hands of a few, it will eventually dissipate out to some. We actually have to design them to be distributed in the first place. And in her TED talk, A Healthy Economy Should Be Designed to Thrive, Not Grow, she argues that our entire economic theory is based on growth at all costs. And what's happening is we end up having a biological result of a system that continues to grow while depleting its host, which is our economy, is the equivalent of a cancer in biology. And yet we can have thriving, healthy forests in the world that continue to grow while actually increasing the value and health of its host. And we need to mimic our economic systems based on that. And she suggests the 21st century economics should recognize that we live on spaceship Earth with boundaries, and not only ecological boundaries, but also social foundations. And at the moment, we've overshot every single one of those social foundations, putting our social structure in extreme jeopardy, and our ecological structure is now also being pressurized to the nth degree. And if we added an exponential curve right now to business as usual, that would just explode us in some horrible sci-fi, horrible future potential of the world. So what if we took the way that a forest grows in cyclical, regenerative, distributed, and diverse ways, and we used that as the way that we developed our economies, and we developed our cities, and we developed our economic and industrial structures, even our agricultural structures? Then we could have a world that could be very exciting, because it would be distributed and regenerative at the same time, or resilient, agile, and regenerative at the same time. So before I end with the last ones, any questions on resilience? Okay.
Nothing, Claire, thanks.
Okay, awesome. So regenerative is what I really am excited for, the potential for humanity, not just to be sustainable. I mean, sustainable is so boring. If I asked you, how's your relationship, when you said sustainable, that's just like not what we're aiming for. You want to have a regenerative, exciting future, not only for your relationship, but for the world. So we want to move away from being degenerative, away from being just sustainable, to being regenerative. And every single organism, every single ecosystem in the natural world is regenerative. And as we understand the principles of regeneration and apply them, we can move away from these linear economies that take, make, and waste things, to start to cycle all our nutrients in closed loops that are always upcycled in exciting ways. But it requires us to shift our design of everything from the level of chemistry, product design, to architecture, to community design, all the way up through industrial ecology, and then into planning at a national scale. It requires us to think regeneratively at every scale, which is exciting for anyone who's finishing school and going into the world of work. We've got to reimagine so many different things and not continue business as usual. And we can see the power of it applied to agriculture. If any of you've seen the film Kiss the Ground in Netflix, you'll see how much better the world is when we actually design our farms to function with nature, not try and fight against it. There's people who are starting to apply this thinking to businesses and how businesses themselves could be regenerative. And to industry, there's this factories that try and function like the natural world and produce as many ecosystem services as nature does. And these are well-being economies designing our economies to be regenerative. And we have the potential to not only restore the environment, but to make money at the same time. And that would actually be the same process, just like all natural organisms are continuing to grow and to flourish and exchange and build resources while nourishing life at the same time. That's what Spaceship Earth requires of us as well. So we combine them all together in an integrated way. We could start to have buildings that actually nourish life. These are some of the designs by Vincent Calabo, who's a well-known biomimicry architect. This is a design he has for India and Delhi, where the entire building not only produces its own ecosystem services in terms of energy, cleans its own water, captures its own water, but at the top you'll see those beautiful glass structures. Those are actually greenhouses to producing its own food. How far could we go if we actually deliberately and intensively designed our world to be regenerative? And then we could design our cities to be regenerative as well. This is a city we designed for Abuja, where we designed the entire city around cyclical metabolisms, where we looked at the way materials actually flowed, water flowed, and we designed the city around those flows. And each of the parts of the city were broken into distributed components like cells that come together and actually form like a living system, distributed network. You can see each one captures and cleans its own water. Each one captures and cleans, captures its own energy, and it can be run on a smart grid. It looks like an intelligent living organism rather than just an old gridded structure of that hierarchical mindset that we try to manage cities by. And then our cities themselves could actually start to function. This is around Durban, where we designed an idea where the gray of the city, what if it functioned like the green that was there before? What if instead of relying on a catchment area upstream with the dam on it, and then building a city that's an ever-increasing desert or floodplain, depending on how you view the tar and cement that covers over it. What if we actually mimic the way that that catchment captures, stores, and sinks water, and we applied that to our stormwater management? Wouldn't our cities look more like this, with the ability to actually turn water into value wherever it lands, not pushing it away from our city at rapid high speed, and actually calling it in and encouraging it to come, actually generating the weather we want, not the weather we don't, by designing deserts. And we can do it with everything from designing cities that hold carbon and cycle it, and hold phosphorus and sediment and all the important things. But essentially, we can design cities that are generous. And I use the word city because it's the bigger picture of humans' impact on the world. If every ecosystem provides ecosystem services, when we emulate nature's genius, can do it too in our cities. And we've done about 3 or 4 cities in this way, and it's very exciting. So this will make sense to the IT people. But as we're loading our human development into the future, instead of us covering over the green, what if that black was actually functioning in the same way as the green? You wouldn't be able to tell the difference, because both would be creating conditions conducive to life. Both would be adaptive and agile and integrated, and it would be very exciting. And we wouldn't have to predict futures that looks like this, or that replace all life with just technology and it looks lovely, but how do we breathe, basically? What if we actually combined the best of nature's genius and wisdom with the best of human intelligence, and designed a future that we could be truly inspired by? Our future is not to be predicted, but created. And we go after a future that we predict. We don't go after a future that is not predicted in somebody's imagination in the first place. And I think it's a very exciting time to be alive if we could actually design a world that not only provided all the best of what we love from our technologies, but nourished life at the same time. And I hope that you, with all your genius around software, will be part of this future evolution for humanity as well. Yeah, so I think these are important and critical skills for us to learn, and I highly recommend you do. I've managed to organize with Learn Biomimicry that you can have a special discount for this online course. It's what Forbes called the online course to work on during lockdown. I think I can share this with you in an email, but the code is synthesis 15 off. I think that's what they sent me. I'll make sure you have the actual one. And yeah, and you can learn online, or you could come with us on expeditions and solve whatever challenges you like, or learn biomimicry that way. Or you could be part of our global biomimicry design challenges, where we leverage a platform with design thinking and biomimicry thinking to solve design challenges. And it's like the X Prize of biomimicry. So thank you for your time. I'm here for a little bit longer to answer any questions that you might have as well.
Wow. Any questions, guys? Or comments? I think from my side, Claire, thank you so much for this. It was utterly breathtaking in how we don't understand this incredible planet that we live on and the lessons that it can teach us. I mean, I personally feel that slime mold and spiders have had this like hate speech campaign against them by Hollywood, and we really need to neutralize that, because they are such incredible organisms that can teach us so much. It was really, really fantastic. The comments coming through on the chat saying, awesome, thank you, Claire, so insightful and interesting from Mike. Claire saying, absolutely fascinating, and beyond that, it creates hope for a better world, very eye-opening. And Stefan saying, keep sharing this with the world. So lots and lots of fantastic and positive comments. We really appreciate your time and sharing this incredible insight with us. Hugo, question? I'll go to you.
Thank you. Yeah, I went to learnbiomimicry.com and I found an interesting quote which says, biomimicry has the potential to change not only our worldview, but also our world. Which is, I guess, very true. Like from this presentation, it did challenge some thoughts that, you know, I'm the separate consciousness that needs to survive, you know. It sort of pitched that worldview that we are actually one organism, you know, maybe experiencing a separate experience, but if we don't recognize the fact that we are sort of in this one spaceship, like we said, Claire, like that's the challenges I think we also have to fight for, is that thinking, right, of how economics and everything, how this world, you know, how should we view the world and how should we view each other? How sort of from your experience, Claire, has that like become a blocker of many of these great initiatives, like trying to change people's worldviews in that sense?
Well, the exciting part is actually that the problems of the world are only a problem of perception, and it's simple to change perception. It's difficult to change big systems, but if you change perception of the people who design our world, then they will go after and design the world differently. So what I'm going to say is 10, 12 years ago when I started studying biomimicry, we knew about the potential of mimicking the spider's web. And now, you know, 12 years later, there's 3 or 4 companies that are already doing it. We knew about the potential of mimicking photosynthesis, and now it's happening. So I think it's just the moment you open up the, you know, think outside the box, think outside. The moment you open up to this adjacent possible and you see that the potential lies there, the power of biomimicry is that it already exists. So it's already proven. So we just have to figure out how it exists and reverse engineer it. So I find the perception shifting is actually the easiest part, because we can say, look, it's right outside. It already exists. We just have to figure out how to do it. So that's
sort of just the educational process, not an argumentative process.
Yeah, exactly. And besides, we look for the both and go for the flow of least resistance. We don't go up against the walls of resistance. We go to find those ones who most understand the need for change and wish to do it with us.
Brilliant. Yeah, thanks, Claire.
Pleasure.
Guys, I will, I have posted the link to the feedback form in the chat again. I will, as usual, send you a bunch of links after this. I've made some notes of some of the book references that Claire's had. I'll send you that link to the biomimicry course with the discount code. Highly recommend that, that, you know, if you really want to learn more about the stuff that you get involved. And then, you know, reach out to Biomimicry South Africa and have a look at the incredible work that they do, and support that organization in whatever way you can if you want to get involved. From my side, thank you very much for attending. Once again, such an motivating and brilliant performance and presentation. Thank you very much for joining us, and I hope you all have a fantastic Wednesday.
Thank you. Cheers, everyone.
Cheers.
Bye.
Bye.
Thank you.
Thank you.
Thanks so much.